Hello viewers and dear students, in this video I'll continue with the 4th unit probability distribution. In my previous video on probability distribution I gave an introduction on random variable. In this video we'll see what is probability distribution and in particular how to write the probability distribution of a discrete random variable. It is based on the student support material uploaded by CBSE. Now let us take an example first to understand what is probability distribution. Now consider a random variable x defined as sum of digits on rolling of 2 dice. So the experiment is rolling of 2 dice and we are considering a random variable x which is defined as the sum of digits on the rolling of 2 dice. Now the sample space of this experiment, it is given by, we know the sample space is, it is given by s is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then we have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This is the sample space of the experiment rolling of these 2 dice. So like this the sample space goes. Four 1, 4 2, 4 3, 4 4, 4 5, 4 6, 4, then 5 1, 5 2, 5 3, 5 4, 5 5, 5 6 and 6 1, 6 2, 6 3, 6 4, 6 5 and finally 6 6. So this is the sample space of this experiment rolling of 2 dice. Now we are considering a random variable x which is defined as sum of the digits which we get on rolling these 2 dice. So here in this case the sum of the digits is 2, then here it is 3 1. If the outcome is 1, 2, then the sum of the digits is 3, and if the outcome is 2, 1 also the sum of the digits is 3. Then coming to this 1, 3, 2, 2, 3, 1, in all these cases the sum of the digits is 4. Like that it will continue until the sum of the digits is 6 plus 6 equal to 12. So the various values which x can take are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So the random variable x can take all these values. Now let us summarize this in the form of a table. So if we summarize in the form of a table, here we can see that 1 plus 1 2, 1 plus 2 3, 1 plus 3 4, like that it goes. And finally we get 6 plus 6 12. So x can take values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are the various values which x can. Now we can find the probability for each random outcome. So if x takes the value 2, then the probability of x is equal to 2, it is only 1. Only when the occurrence is 1, 1, x can take the value 2. So the probability is given by number of favorable outcomes divided by the total number of outcomes. Total number of outcomes, we know it is equal to 36. Total outcome is 36. So, and the favorable outcome is only 1, which is 1, 1. So, probability of x is equal to 2 is 1 by 36. Then coming to probability of x is equal to 3. Probability of x is equal to 3. The number of favorable outcomes will be, it will be 1, 2 and this 2, 1. In these two cases, the value of x is 3. So, the probability, associated probability is 2 upon 36. Then the next one is 4. That is probability of getting a sum equal to 4. So, here we can see we have these three cases where the sum is 4. So, in these three cases the sum is 4. So, the probability of x is equal to 4 is 3 by 36. Then considering probability of x is equal to 5. So, the sum of the digits will be 5 in all these cases. That is 4, 1, then 1, 4, then here it is 3, 2 and here it is 2, 3. So, in all these 4 cases the sum will be 5. So, the probability of getting a sum as 5 is 4 upon 36. Then the next one is probability of x is equal to 6. Here these are the cases where the probability of getting a 6. So, the number of favorable outcome is 1, 2, 3, 4 and 5. So, probability is number of favorable outcomes divided by total number of outcomes. So, it is 5 upon 36. Then probability of x is equal to 7. Number of favorable outcomes is 1, 2, 3, 4, 5, 6. So, it is 6 by 36. Then the next one is probability of x is equal to 8. Number of favorable outcome is 1, 2, 3, 4, 5 and total number of outcomes is 36. The next one is probability of x is equal to 9. So, in all these cases the sum of the digits is equal to 9, that is 1, 2, 3, 4. So, number of favorable outcomes is 4 and total number of outcomes is 36. Then the next one is x is equal to 10, it is in these three cases. So, the associated probability is 3 upon 36. The next one is x is equal to 11, the associated probability will be 2 upon 36. And finally, probability of getting a 12, there is only one possibility. So, the associated probability is 1 by 36. So, we have considered a random variable x which is defined as the sum of digits on rolling of 2 dice. We have written the sample space of the experiment and from that we have found the value which x can take. So, the various values which x can take are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now, we are finding the probability of each of these outcome. So, we are finding the probability when x is equal to 2, x is equal to 3 up to etc. and writing it in a form of a table. So, the probability of x is equal to 2 is, it is 1 by 36, probability of x is equal to 3 is 2 by 36, 4 is 3 by 36 up to etc. till 12. This way of representing the outcome of a random variable and the associated probability is called the probability distribution. Here we can see that x takes only distinct countable values. So, we can say x is a discrete random variable. So, the probability distribution of a discrete random variable is represented in this form. It is a table which shows the value which the random variable takes and the associated probability for each value. This is called probability distribution of a discrete random variable. Now, coming to the definition, the table of possible outcomes and their respective probability is called probability distribution table for the given random variable x. A probability distribution table links every possible outcome of the random experiment with the probability of the event to occur. So here we can see that the probability distribution table, it links every possible outcome to its probability. So this is a probability distribution table. And one more important thing is, in a probability distribution table, the sum of all the probabilities is 1. This is the most important condition as far as probability distribution table is concerned. If the sum of all probabilities is not equal to 1, then we cannot say the given table is a probability distribution table. So here if we add all these, the denominator is 36, so the LCM will be 36. So here 1 plus 2 3, 3 plus 3 6, plus 4 10, plus 5 15, plus 6 21, plus 5 26, plus 4 30, plus 3 33, plus 2 35, plus 1 36. So here if we add all these, we get 36 upon 36, which is equal to 1. This is the most important condition for probability distribution to be satisfied. If this does not add up to 1, then we cannot say this as a probability distribution table. Here it adds up to 1. So it is a probability distribution table. So whenever we are asked to find whether the given distribution is a probability distribution or not, then we have to add the probabilities and check whether it is equal to 1. Now we will see one more example. A coin is tossed thrice and outcomes are recorded. Prepare the probability distribution table for the number of hits. So here a coin is tossed these 3 times and the outcomes are recorded. We have to prepare the probability distribution table for the number of hits. So let a random variable x denote the number of hits in 3 tosses of a coin. So first let us write the sample space. The sample space of this experiment, that is tossing a coin 3 times. The sample space is given by, it can be head, 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 or head, head, tail, or it can be head, tail, head, tail, head, 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 tail, 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 head, tail, head, tail, tail, or tail, tail, tail. So these are the various outcomes of this experiment. Now if we see here, x denotes the number of heads in this experiment. So here it can take the value 3, then in these cases x can take the value 2, and in these 3 cases x can take the value 1, and here x can take the value 0. So the various values which x can take are 0, 1, 2 and 3. Now we know that probability of getting a head is equal to half, and probability of getting a tail is also equal to half. Now let us find the probability of each outcome, that is probability of x is equal to 0, then probability of x is equal to 1, then 2 and then 3. So first let us find probability of x is equal to 0. So this is possible when all 3 are tails. So this gives probability of x is equal to 0. This is nothing but using the multiplication rule of probability. It is equal to half into half into half. So it is equal to 1 by 8. Then let us find probability of x is equal to 1. Now this is possible when we have these outcomes HTT, THT and TTH. In all these cases, we will have x is equal to 1. So it is obtained by total number of trials, 3 C, and number of success. Here the success is 1, we get 1. So it is 3C1 into 1 by 2 into 1 by 2 into 1 by 2, that is equal to 3 by 8. Now the next one is probability of finding x is equal to 2. Now we will get x is equal to 2 in these situations: HHT, HTH and THH. In these cases, probability of x is equal to 2, it is given by, it is 3C2 into half into half into half. So this is equal to 3 by 8. How this 3C1 comes, 3C2 comes, all these will be easy to understand after studying binomial distribution after 1 or 2 topics. Then finally, probability of getting 3 H's. This is given by probability of x is equal to 3 and it is half into half into half, which is equal to 1 by 8. Now let us write the probability distribution table after finding the probability of each outcome. So probability of x is equal to 0 we calculated as 1 by 8. So when x1 is equal to 0, probability of x1 is given by 1 by 8. Then the next one, probability of x is equal to 1, we calculated as 3 by 8. So this is 3 by 8. Then probability of x is equal to 2 is also equal to 3 by 8. So probability of x is equal to 2 is 3 by 8. And finally probability of x is equal to 3, we found it as 1 by 8. So this is 1 by 8. Here we can see that if we add all these, we will get 1. 3 by 8, I am sorry, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. It is equal to 8 by 8, which is equal to 1. So the sum of all these probabilities, it is equal to 1. So this is the probability distribution table of this random variable x, which denotes the number of heads in 3 tosses of a coin. Now these are the questions from the check your progress section of Unit 4 probability distribution in the student support material. State which of the following are not probability distribution of a random variable. Give reasons for your answer. So the first part, A part. So this is a table which is given and this is the random variable which takes values -1, 0, 1 and 2, and these are the associated probabilities of this x. So it is given probability of x is equal to -1 is 0.1, x is equal to 0 is 0.8, 1 it is 0.001 and 2 it is 0.2. Now if we add all these, and see 0.1 plus 0.8 plus 0.001 plus 0.2, it adds up to 1.101. Now this is not possible. That is the sum of all these probabilities. It should be equal to 1. That is the condition for probability distribution. Summation pi, it should be equal to 1. Now this is more than 1. So this is not a probability distribution. So we can write no, since summation pi more than 1. Now coming to the next subdivision. So this is the table which is given. When x is 1, the associated probability is 0.1, x is 2, probability is 0.4, x is 3, probability is 0.05. When x is 4, probability is -0.2. This is not at all possible because the value of the probability always lies between 0 and 1. So this is also not a probability distribution, since we have pi less than 0. This is not possible. Negative probability is not possible. Now coming to the last subdivision, when x is minus 2, probability is 0.5, x is 2, probability is 0.2, x is 5, probability is 0.3. Here let us add the probabilities. Summation pi is 0.5 plus 0.2 plus 0.3. It is equal to 1. So it is a probability distribution. So this is a probability distribution table. The next question, a lady's bag contains 2 black and 1 red pens. One pen is drawn at random and then it is put back in the box after noting its color. The process is repeated again. If X denotes the number of red pens recorded in the 2 draws, describe X. So in this question, it is given a lady's bag contains 2 black and 1 red pens. And it is also given one pen is drawn at random and then it is put back in the box after noting its color. And this process is repeated again. We are asked to take the random variable X as number of red pens recorded in the 2 draws. Now we have to describe X. So let us take, let the pens be, we have 2 black pens and 1 red pen. So let the pens be given by B1, B2 and R1. Now let us write the sample space. So the sample space, the experiment is one pen is drawn and then it is put back in the box after noting its color and the process is repeated again. This is the experiment. So the various outcomes can be, it can be both the first black pen or first black pen, second black pen, or second black pen, first black pen, or it can be both second black pen, or it can be first red pen and first black pen, or red pen and second black pen, or first black pen then red pen, or second black pen red pen, or both can be red pen. So these are the various outcomes of this random experiment. So here we can see that X takes the values 0, 1 and 2. So if we are asked to describe X, X denotes the number of red pens recorded in the 2 draws. Here if we see, in all these cases X is equal to 0. That is X of B1 B1, X of B1 B2, X of B2 B1 and X of B2 B2. In all these cases, the value which X takes is equal to 0. Then in these cases where one red pen is possible, so X of R1 B1, R1 B2, B1 R1 and B2 R1. In all these cases, the value which X takes is 1. Then when the outcome is both red pens, the value which X takes is 2. So this is how we can describe X. So the various values which X takes are 0, 1 and